Radicals, or sometimes known as surds, are numbers that are non-perfect powers that are inside roots. So for example, 5 is not a perfect square. If we put that into a square root, we cannot get a whole number that multiplies itself that gives us 5, or a whole number squared that gives us 5. Or in fact, we can't even find a fraction that's squared that would give us 5. So if we have a fifth root, okay, we want a fifth root of 16, means that some number multiplied by itself to the power 5 is equal to 16. Well, there's no whole number or rational number that will give us that number. The cube root of 53, there is no perfect cube of 53, so we cannot undo this 53 with the cube root. So these numbers we first kind of encountered as mathematicians long time ago. They were really sure what to make of these numbers, because when they actually worked out the diagonal of the square, they worked out the diagonal length was some number that we now know as root 2, but they didn't know how to write that number, because that number they couldn't quite figure out how long it was. They couldn't write it as a fraction. And so it took a long time for them to kind of accept that this number was not a fraction. And in fact, it's a different type of number, and it is an irrational number. So this number here is a number that is never repeating and never terminating. And we can express these numbers, these irrational numbers, in kind of two ways. We can express them as a mixed radical or an entire radical, where we have the perfect square factors that are inside the root can come outside, which in this case here is square root 72 and 6 root 2 are the same number. There's a perfect square factor of 36 when we square root it, can be expressed on the outside as 6. And so these two numbers are equivalent. One is what we call a mixed radical because it has a number part and a radical part, and this one's an entire radical because the entire number is under the radical. And there's different times when we would use these. So mixed radicals are useful when we do algebraic manipulations because we want to see what the lowest term radical is. And what we can then find out then is if we have what we call like radicals. And if we have like radicals, we can combine like radicals, just like we can with like terms. Whole radicals, on the other hand, are a lot easier to compare with one another because we can see square root 72 that it would be bigger than square root 71. Okay? And we can compare these radicals with each other much easier if we can see the entire radical under the root. So we want to be able to convert radicals from their entire form to their mixed form, and we're going to have a process of doing this. And we're going to I want you to watch this video, so go to the link of this video, and it will give you an idea of how we can convert radicals from entire radicals to mixed radicals, and vice versa.